Here on the 4th floor of our building in the Conrad wing is the EMC Lab. Come on. Hi, this is my colleague Otto. Hi Otto.
Hi John.
So today we'll investigate how you guys make sure that electronic devices are electromagnetically compatible with their surroundings, right?
That's right.
So what does EMC stand for? What is it?
Yeah, so EMC stands for Electromagnetic Compatibility. This means ensuring that electronic devices can function without creating or being affected by electromagnetic interference.
Ah.
So this is very important to make sure that products work as intended and do not disturb each other. So therefore, by law, a product must meet strict regulatory requirements before being sold. And testing the device in an EMC lab like this basically evaluates compliance with these requirements.
So Otto, tell me, power grid immunity, what do you do here?
Yeah, so here we perform tests that focus on the power grid immunity, as you said. We simulate real-world power conditions to ensure a product can handle different disturbances coming from the mains power.
Okay.
So it could be events like lightning strikes or just interference coming from other equipment connected to the same electrical system.
I see something behind you that looks like a high-tech stun gun. What is that?
Yeah, so this we use to generate electrostatic discharges, like when you get a static shock from touching a metal surface, for example. So electronic devices can be very sensitive to this, so here we can replicate discharges in a controlled way and ensure that the product can withstand it.
So what's the next step in the testing process?
Yeah, so now we perform a series of tests checking for what's typically higher frequency interference. We start with immunity testing, which is related to how the device handles external interference. This is done both conducted and radiated, first by injecting interference into power and signal cables, and then by exposing the device to a strong electromagnetic field inside of a shielded chamber.
So you really make sure that the devices can survive even when surrounded by wireless signals or electrical noise?
Yeah, exactly.
So far we've seen how devices resist interference, but what about the interference they create themselves?
Yeah, good question. So we have a corresponding setup for emission testing as well.
Ah.
Here we instead measure electromagnetic noise coming from the device itself, either through the cables or through the air.
So why is this important?
So just like we test immunity to interference, we also need to make sure that the product is not causing harm to other devices nearby.
This looks cool. What makes this chamber so special?
Yeah, this is our most advanced chamber. It's much larger in order to meet the full requirements of FCC, the American regulatory body. But it also allows us to measure at much higher frequencies, up to several hundreds of gigahertz.
That's really impressive. So you measure cutting-edge technology in this room.
Yeah, it's very versatile. Even specialized equipment such as high-frequency radar systems can be tested here.
How does this help clients developing new products?
Well, by performing EMC testing early in the development process, we help customers avoid costly redesigns later on. And in addition, proper pre-compliance testing is also a cost-effective way of ensuring compliance before going to final certification. So this saves time and greatly reduces risk for our customers.
It's been extremely fascinating to look at all of these EMC labs with you, Otto. Thank you so much.
Thanks for having me.
Don't forget to like, subscribe and comment on this video. And if you reach out, you can book a lab tour for you and your company to come and visit us in person. I'm John, this is Sigma Connectivity. Have a beautiful afternoon.